Hello everyone, hope you all are doing well. Yesterday we have completed our topic that was thermochemistry and our redox reaction was remaining. So let's continue with redox reaction. Actually, what is redox reaction? Redox reaction, in this the oxidizing agent convert into reducing agent is called reduction. Like oxidizing agent is a gaining of electron. Previously, we were having reduction, that was gaining of electron, and oxidation, that is losing of electron. But here is the opposite of that. Oxidizing agent is doing work similarly as reduction, and reducing agent is doing similar work as oxidation. So here oxidizing agent convert into reducing agent, like it's gaining electron convert into reducing agent, and it is called reduction process. Let's take an example. Here we are having oxidized state, like here it's gaining a one electron, and it's become a reducing state. Like reducing agent means, like uh, reducing agent means the negative, means negative agent, or oxidizing agent represented as positive agent, means the gaining of electron. When you gain a electron, okay, you have a positive charge, means gaining of electron, you have a positive charge on it already. You gain one electron, you will be the reducing agent, you will be in the reduced state. Let's take an example of aluminium. Here we are having aluminium, okay, it's in a oxidized state. Now we are adding 3 electron in it, so it will convert into reduced agent, it will goes into reduced state. Like it is having a positive charge first, it was having oxidized, means it's gaining of electron. When it's gain electron, so it convert into reducing agent, like now it will lose its electron. So oxidizing agent means, oxidizing agent is the gaining of electron, where oxidizing agent convert into reducing agent. Let's uh, take another opposite of same that definition, that reducing agent convert into oxidizing agent is called oxidation. Like previously we were having aluminium plus 3 electron, it's making aluminium, it's going into reducing state. Now this reducing state all again convert into oxidizing agent, and that process is called oxidation, where reducing agent is losing its electron. Like we are having reducing agents over here, like sulfur, calcium, aluminium, and when it's lose its one electron, like sulfur 1 electron, calcium 2, aluminium 3, they are losing their electrons. When it's losing their electrons, so it will take an oxidizing agent, it will make oxidizing agent, means gaining of electron. Why gaining of electron? Because it's already lose its electron. So the question arises that why it will gain electron, like because now it's have a capable to gain electron. Like firstly it was reducing agent, it was losing its electron. When it's lose its electron, so it become these sulfur, calcium and aluminium becomes oxidizing agent, like they are capable to gain electrons. Okay, let's move to another topic, that is oxidation number. In oxidation number, it is a property of an atom in a compound or iron. Like it's a property of an atom in a compound. Like we are having atom in a compound or a ion. It's a property of that. Its value may be positive, negative, or zero, depending upon the charge of combined atoms in a molecule or ion. What is the charge of the on the compound, that depends that what oxidation number it is. Like we are having Na is a simple element, so we cannot imagine oxidation number of it, we just imagine the oxidation number of ions or compound, like NaCl, it's a compound. Okay, let's move to another part. Here it says that atom in a compound to lose electron number have positive charge. Like if any atom is losing its electron, like aluminium having 3 electrons and it's losing its electron to become aluminium just, okay, to being a oxidizing agent, so this will get a positive charge here. Like it will get a positive charge when it's losing its electron. So that is written here, atom in a compound to lose electron number have positive charge. Like aluminium lose 3 electrons, so have 3 oxidation number. When aluminium loses 3 electron, so if anyone will ask what is the oxidation number of aluminium, so you will say that 3 is the oxidation number of aluminium. Okay, let's move to another, and we are representing with a positive sign. Let's move to another, that is atom in a compound to gain electron number and have a negative oxidation number. Like we are having chlorine here. Chlorine, it's -3. It's gaining electron, it means it's gaining electron, so it is having -3 oxidation number. If we are taking aluminium and chlorine together, okay, it's having +3 charge and it's having -1. So -1 is a negative oxidation number of chlorine, and +3 is the positive oxidation number of aluminium. This is a method how we can find the oxidation number in positive, negative or 0. Now talking about the valency. Actually valency, it is a property that does not tell about the negative or positive oxidation number. It's just imagine by the number of valency. Like we are having calcium Ca+2, so we know that it's having 2 oxidation number. Same here, we are having Ca2, we don't have a negative sign, we don't have a positive sign in it, so we cannot say that it's gaining electron or it's losing its electron. Okay, so this is called the valency. Now to know oxidation number of, like we are having one compound, that is Al2O3. To find its oxidation number, what we will do, that we will do the cross multiplication. Like aluminium, it's a metal, so we know that it's got a positive, and non-metal negative. Now what we will do to know its oxidation number, we will just cross it. Like aluminium +3 and oxygen -2. So now the oxidation number of oxygen is -2 and oxidation number of aluminium is +3. Okay, it means that +2, it's -2 oxidation number, means it's gain electron, and it means it lose its electrons. Let's move further. How we know about oxidation number? Same here, like I have written many compound here, like lithium, sulfur, potassium, hydrogen, magnesium, calcium, zinc, aluminium, oxygen, sulfur, and more. Now let's talk about first one. Like if we are having NaCl, how we'll find its oxidation number? So we will find the oxidation number of it by the ratio. Like the ratio of Na is 1 and Cl is 1, so it means their oxidation number is 1 and -1. It's +1 because it's metal, and it's non-metal, so -1. With this method we can find the oxidation number of the simple empty compound like NaCl. Now let's suppose we are having CaO. Okay, now how we will find this oxidation number? We will find this oxidation number with the oxygen. Like we know that the valency of oxygen is 2. When valency of oxygen is 2, then we'll cross multiply it, so it means calcium having +2 and oxygen having valency of 2, so it's -2. So this is the oxidation number of oxygen, and this is the oxidation number of calcium. Let's talk about another. Like we are having AlCl3. Now as I told you, we will do here cross multiplication. So here cross Al3 and here is nothing, so it means 1, so it is 1. So it means the oxidation number of chlorine is -1 and aluminium is +3. These are the diatomic. We find the valency oxidation number of diatomic. Now what we will do in triatomic? So let's take an example of triatomic. We are having potassium, we are having chlorine, and we are having oxygen 3. Now as we know that potassium is a metal, so it has positive charge. Chlorine is a positive charge metal. Oxygen will negative charge because it's non-metal. Now we know the valency of oxygen. We know that valency of oxygen is 2. We write 2 here. Now what we will do, we will multiply these both. So 3 2s are 6. 6 came over here. Now after that, we know that the oxidation number of potassium is plus 1. So we will put 1 over here. Now 6 minus 1, we are having remaining 5. So it means here will be the oxidation number 5. Now if we are adding 5 and 1, so it will make 6. So it means that the oxidation number of potassium is 1, chlorine is positive 5, and oxygen is negative 2. This is the method how we can find the oxidation number of triatomic. Now let's suppose at the place of it, we are changing the position of it. We are having C6H12O6. we will put minus 2 here. Hydrogen metal positive, calcium carbon positive. Now what we will do, that 6 2s are 12. 6 2s are 12. So what we will do, we know that our valency of oxidation number of hydrogen is 1. What? 1. So when hydrogen number of oxidation number of hydrogen is 1, so what we will do, it's 12 ones are 12. 6 2s are 12 and 12 ones are 12. So it means there's a no oxidation number in carbon. 0 oxidation number in carbon, hydrogen 1 oxidation number, and oxygen 2 hydrogen number. Okay, in this method we can find the oxidation number. Let's talk about let's talk about non-metal and non-metal. Like we are having two non-metals over here, calcium and oxygen. How we'll find the oxidation number of it, because both are non-metal? So we will use a technique that is called the electronegativity. By electronegativity method, we can find the oxidation number of it. As we know, we are having higher higher electronegativity of oxidation. So what we will do, we will more electronegativity in oxygen, so means it have a negative, which is having more electronegativity, it means that will get a negative charge and it will get positive charge. We know the valency of oxygen is 2, so it means 2 over here. So the oxidation number of carbon and oxygen both are 2. Okay, this is the method to find the oxidation number of non-metal. Hope you understand how to find oxidation number, valency, and how to know how we know about the redox reaction. Make sure you are checking the difference between oxidizing agent and reducing agent, and reduction and oxidation. So this is all about our today's topic. If you have understood, kindly like, share and subscribe. If you have any question, do write your question in comment and I will reply you as soon as possible. Till that, thank you.